Hello everybody, welcome back to Bepharmawise. Today we are going to discuss principle, procedure, reaction, calculations, everything about standardization of hydrochloric acid solution. So, what is standardization? Let's first understand it. See, in analysis we know there are two types of substances, primary standard substances and secondary standard substances. Now, primary standard substances are the one which are absolutely pure with very little amount of impurities, and if we say that we have prepared a particular concentration of that substance by dissolving a suitable amount in a appropriate volume, then actually that concentration can be considered as achieved. For example, oxalic acid is a pure primary substance. So when I say I had dissolved say 6 grams of oxalic acid in 1 liter of solution and the solution is 0.1 molar, then actually the solution can be considered 0.1 molar. This is I have taken just as an example. The calculation may not be correct. Just for the sake of understanding, understand this, that for a primary standard substance, when we calculate the exact amount necessary for making a particular solution, when we dissolve that amount in a given volume of solution, the desired volume of solution, then that concentration can be considered accurate. But this is not the case for the secondary standard substances. Secondary standard substances are not that pure. They do not meet the specific criteria of primary standard substance. That's why we call them secondary standard. Now, when I say I have dissolved a particular amount of substance in a particular volume and the concentration is approximately 0.1 molar or 1 molar, then I have to make sure what the actual concentration is. Theoretically, approximately I have prepared a concentration, and now by some process I have to actually decide the concentration of the solution. This process can be done by comparing that secondary standard substance with a primary standard substance solution, and this process is called as standardization. In standardization, we actually determine the concentration of a secondary standard substance by comparing it with a primary standard solution. So in this case, in this video, we will be talking about standardization of 1 molar HCl solution. Now, HCl means hydrochloric acid is a secondary standard substance. Now, first let's discuss the preparation of 1 molar HCl. So, for preparation, what I have to do, 85 ml of HCl, concentrated HCl, has to be dissolved in water to make 1 liter of solution. Now, how we are going to achieve it? First, we will take 500 to 600 ml of water in a volumetric flask of 1 liter. In that water, we will slowly and carefully add 85 ml of HCl. Then we will make up the volume to 1 liter. We have to always add concentrated acids in sufficient volume of water, but not the other way around. You cannot add water to acid. You will not take 85 ml of acid in flask and then add water. No, we have to take water, sufficient water in the volumetric flask, and then we will add acid to it. It will avoid splattering. Now, after preparation, now I know that in my volumetric flask there is 1 molar HCl, theoretically, approximately. Why? Because it is a secondary standard solution. Now what I have to do is I have to actually determine the concentration, exact concentration. So I will go for standardization. So first, for standardization, I am choosing volumetric analysis, means titration. So for titration, it is an acid. So I will need a base so that I can go for acid-base titration. And that base has to be a primary standard substance. So as my acid is a secondary standard substance, the base I'll be choosing has to be a primary standard substance. So I'm going to choose sodium carbonate Na2CO3 as my base. Now as you can see, HCl is a strong acid and sodium carbonate is also a strong base. So it is going to be strong acid, strong base kind of titration, aqueous acid base titration. Now what we will be doing? So let's now learn the procedure. So what I will do, in the conical flask, I will exactly weigh whatever amount of sodium carbonate specified in the procedure. Let's say we will weigh 1.5 gram of sodium carbonate anhydrous. Okay, it has to be previously dried for 1 hour at 270 degrees Celsius. Then it is completely anhydrous. At that way, you ensure that the primary standard is exactly pure and free of any moisture. So that 1.5 gram sodium carbonate I have accurately weighed on a sensitive balance and taken into the conical flask. Now I will dissolve it in sufficient amount of water, say 100 ml of distilled water will be used, and then a suitable indicator will be added. In this case, methyl red is a suitable indicator. So methyl red indicator will be added, and now this solution of strong base I will titrate with 1 molar, which is the prepared 1 molar HCl solution. Now I will remove this 1 molar HCl solution filled in burette. I know that I have prepared it to be 1 molar, but at the end of the practical I will come to know what is the exact concentration of that HCl, which is called as standardization. Now let's carry out the titration and we will get a reading. Take multiple readings, 2-3 readings, average it out, and then I have the burette reading required. Burette reading means ml of HCl required to completely react with 1.5 gram of sodium carbonate. Say that reading is YmL 25 ml, for example. Okay. Now let's move on and understand what is the principle of this titration and what are the reactions involved in it. So in principle, we can definitely say that this is a strong acid, strong base type of titration. It is aqueous acid base titration where methyl red is used as an indicator, and the sodium carbonate is our primary standard substance, which is a basic substance. It is a diacidic base. Now let's come to reactions. What are the reactions going on? So here HCl is getting reacted with sodium carbonate. Now HCl, it is a monobasic acid, means it produces only one H plus ion which can neutralize only one base. But sodium carbonate is a diacidic base, means it can actually neutralize 2 molecules of acid. Okay, so when the reaction we will write, it has to be balanced. So I will write the reaction where I will get 2 NaCl plus H2CO3. Now for balancing the reaction I have to write 2 here. So 2Cl, 2Na, 2NaCl and H2CO3. Now one important point to remember in this kind of titration where you are titrating HCl or sulfuric acid, what happens is, this is a neutralization titration, but as you can see, salt and water is not formed, which is generally the case with neutralization. Salt and water has to be formed, but here a weak acid is formed, carbonic acid. Now what we have to do to reach to the exact end point, what we will do is, once you start titrating, a faint pink color will be obtained at the first place. You will not stop the titration there. Now what you will do, you will boil the content of the conical flask for a few seconds, and after that boiling, your color might disappear. Now why this happens? Because that color can be a false interpretation because of this weak acid. The reaction is not yet complete. When the reaction will be completed, once you boil the solution for a few seconds, this carbonic acid actually splits into water and carbon dioxide. Now carbon dioxide escapes into the environment and only the water is left. So once this reaction is complete, your neutralization is actually complete, because now you have salt and water and the carbon dioxide is evolved. right? So after boiling, you have to continue the titration. Then the pink color appears. Then you boil the solution. Then continue the titration. You have to continue the titration till the pink color you are obtaining is no longer affected by this boiling. If the color is getting disappeared after boiling, it means titration is not complete. But when even after boiling the pink color is persisting, that means the titration is complete. That is your end point, and that reading you have to consider for further calculations. Now I hope the principle, procedure and reaction is clear. Now we will go for calculations. Now for calculations, what we will do? For calculations, we are going to use equivalence factor method. So I will show you how we are going to actually calculate the results. So for equivalence factor method, always remember we have to start with a balanced chemical equation. So in this case, 2 moles of HCl react with 1 mole of sodium carbonate to give 2 moles of NaCl and carbonic acid. This carbonic acid upon boiling splits to water and carbon dioxide, which gets escaped into the environment. So this is my balanced chemical reaction. Now who is our analyte and titrant in this case? So sodium carbonate and HCl, they are one in the conical flask, one in the burette. So what we will do, we will always write the equivalence factor in a way that the liquid component comes on the left hand side. So who is the liquid component? Sodium carbonate I had weighed 1.5 gram in the solid state and taken in the conical flask. So I will keep it on the right hand side, and the liquid component I will take on the left hand side. So 2 moles of HCl are equivalent to 1 mole of sodium carbonate. This is my basic understanding of this reaction. The 2 moles of HCl are reacting completely with 1 mole of sodium carbonate. You have to write this based on the balanced chemical reaction. Now 2 moles of HCl means, you know what molarity is. Molarity means you are preparing a solution, 1000 ml solution, 1 liter solution, by dissolving the molecular weight of substance into it, that we call as 1 molar substance. Now 1 mole of HCl, how I will be writing? 1000 ml of 1 molar HCl means 1 mole of HCl. 1 molar HCl, how the solution is prepared? By dissolving molecular weight of HCl, or the required volume of HCl in case of acids. They are liquid, so we cannot say molecular weight grams, but the desired volume of that acid in 1000 ml of volume. So it gives me 1 molar, 1000 ml means 1 mole. Now here there are 2 moles, so I will take 2000 ml. So 1 molar HCl, if 1000 ml I take, it gives me 1 mole of HCl. If I take 2000 ml, it gives me 2 moles of HCl. So always we have to convert this moles part in concentration part. So 1 molar HCl, 2000 ml, this comes for left hand side, is equivalent to, now 1 mole of sodium carbonate, it is solid. So I will use the molecular weight. So what is the molecular weight? 106 gram of sodium carbonate. It is the molecular weight of sodium carbonate. So see, molecular weight grams means 1 mole of sodium carbonate. But here for liquids, how you will write? 1 molar solution of 1000 ml. Here 2 moles, so 2000 ml. Now we will come down to 1 ml. So how we are going to do? First we will come here to 1000 ml. 1000 ml of 1 molar HCl is equivalent to, now when you are doing such calculations, what you will do? You will keep one thing constant and you will give the same treatment to the remaining 2. Now in this case I have kept 1 molar constant. So whatever I will do to this, I have to do to this. See here 2000 is converted to 1000, means I have divided by 2. So here also I have to divide by 2. So 106 divided by 2 comes 53 gram of sodium carbonate. Now 1000 ml I will convert to 1 ml. 1 ml of 1 molar HCl. Here also I have kept one thing constant and I have divided this by 1000. 1000 divided by 1000 comes 1. So here I will also divide by 1000. So if I divide by 1000, the decimal point will shift 3 points left. So what I will get is 0.053. See, 1, 2 and 3 grams of sodium carbonate. Now this is my factor. Now suppose if you are not using 1 molar HCl, say you are using 0.1 molar HCl, then you have to go 1 to 0.1. Then you will keep this 1 ml constant. Now you are going 1 to 0.1, so you will go 0.0053 here. So depending on which concentration you are using, you have to modify this factor. So this is my factor. 1 ml of 1 molar HCl is equivalent to this much gram of sodium carbonate. Now what does that mean? What does this factor mean? This factor means that if you are using 1 molar concentration of HCl in the burette, and if 1 ml of that concentrated HCl falls in the conical flask, it is going to react with this much amount of sodium carbonate in the conical flask. Now, what I want to calculate here, I want to calculate the actual molarity of HCl. That is my purpose of standardization. So, I will say my molarity of HCl, whatever I have used, which I have prepared 1 molar, but I don't know exactly what it is. So, I will say X molar HCl. And what I have taken in the conical flask, I completely know. I have weighed, accurately weighed on a sensitive balance 1.5 gram of sodium carbonate. So, I will write 1.5 gram of sodium carbonate here. I will write X molar here. And what I know is, what is the volume of this HCl required, right? So, average burette reading. In that case, we have said it is 25 ml for example. So, Y ml I will write Y ml of, this is going to be my burette reading. X molar HCl is equivalent to this much gram of sodium carbonate. See, now I have a factor where 1 ml of 1 molar HCl is equivalent to this, and then I have another factor where I don't know this molarity, so I have referred it as X molar HCl. But for that X molar HCl, I know the amount of or the volume of that HCl required to completely react with 1.5 gram of sodium carbonate. So I can definitely calculate X using cross multiplication. So X molar HCl or molarity X is equal to, what I will do? I will cross multiply. So 1 into 1 into 1.5 gram. 1 ml into 1 molar into 1.5 gram divided by Y ml, which is my burette reading, into 0.053 gram. So when I solve this, I will get the actual molarity of my solution. So you have to just use a calculator, and one thing you have to be careful. What students I have seen doing is they go on typing 1 into 1 into 1.5, then they divide it with burette reading and then they multiply. So you don't have to do this. First, either you multiply all of these, write it here, multiply all of these, write it here, and then divide. Otherwise, what you have to do is this into this into this divided by this divided by this. Then you will get the accurate reading or calculation. So this is how I will find out. Now, for example, the reading comes or the result comes 0.09 molar. So now what I will write in the results? The molarity of HCl solution, in bracket I will write prepared 1 molar, was actually found to be 0.09 molar. So this is how the standardization is going to help you. You are preparing a solution of a secondary standard substance of a said molarity, and through standardization, through comparing it with a primary standard substance, through titration, you are coming to a result where the exact concentration of that solution is determined. So in the result we are going to mention the molarity of said HCl solution, which was prepared 1 molar, is actually 0.09 molar. So this is the concept behind standardization, and this is the principal reaction procedure of standardization of HCl. I hope I have covered all the important points related to this. I hope you have understood. If you have any doubts, ask me in the comments. I will be happy to help. So that's all about it. Let's meet in the next video. Till then, stay tuned to Bepharmawise. Stay happy. Bye.